SwayamPrabha. Digital India. Educated India.
Hello everyone. Today I am going to deliver a lecture on welded joint analysis. In last lecture I was discussing about welded joint analysis on parallel types of fillet weld joint as well as bar weld joint. Today I will continue from the last lecture, whatever the portion I covered, from that onwards I will start today's lecture. So, last lecture we have discussed already about parallel fillet weld. Today we will discuss first what is the maximum shear stress in parallel fillet weld, then what is its angle with horizontal axis, that also we will show. Then I will discuss about strength of transverse fillet weld. Then I will discuss about problem on parallel fillet weld as well as problem on transverse fillet welds. If time permit, then I will go to discuss about eccentrically loaded welding structure related topics also. So, first of all I will discuss about maximum shear stress in parallel fillet weld. So, we know parallel fillet weld means depending upon the type of loading in a structure, the fillet weld joint can be categorized into two different types. One is called parallel fillet weld and another one is called transverse fillet weld. So, in parallel fillet weld we have already observed, once the load is along the length of this weld direction, that is generally called parallel fillet weld. Like this is a weld, this is a weld, this is along its length, which length of the weld length is L. So, this is also length direction. So, here let this weld is subjected to a load P, which I am showing here. So, as this load is along the direction of this weld length, that is why it is called, that means we can say as the load is parallel to the direction of this weld length, that is why it is called parallel fillet weld. Now, here we will find what is the maximum shear stress in parallel fillet weld, and also we will find what is the direction of this maximum shear stress with this horizontal axis. Let us consider a double fillet weld. This is one fillet weld, this is another fillet weld, both side of a T joint you can say. So, it is subjected to a load P which is parallel to this weld length direction which I am showing here. Now, we have to find out at which angle of this weld this what it is called maximum shear stress is acting, that we are interested to find out. So, for finding out this thing, first of all let us consider a free body diagram of this weld and force system. So, this free body diagram here I am showing in this figure B, you can see. Here let the position of this applied load P, which I am representing by a cross line. The cross, what does this cross line indicates? This cross line indicates the force perpendicular to the plane of the paper which goes away from the observer, and let us consider this dot. Here you see this dot position of the load which is let's acting at the weld plane, with this weld plane which is makes a angle, with this horizontal axis is theta. So, once we balance this applied force P with the resisting force on this weld, as there are two different weld whose length is also equal, that is why what we can say, this is called double parallel fillet weld. Here I am writing double parallel fillet weld. Fillet weld. So, this is the free body diagram FBD, here I am writing FBD. Okay. This is the free body diagram of this loading system, you can say. So, this is the applied force. Let us consider the free body diagram of this fillet weld is which I am showing in this figure B, where generally this applied load is P, which I am representing by a cross line. Why I am representing this thing by a cross line? Because it is generally, as we are taking this side view of this fillet weld, that is why what happens here it is representing like this. Let us consider that the resisting force which is acting in the weld, which is in a plane which makes a angle theta with this horizontal axis which I am showing here. So, this resisting force which is generally parallel to this applied load P, as the direction of this applied load P is toward the plane of paper away from the observer. So, the direction of this load which is resisting load inside this what is called weld, which should be towards the direction of the observer. This you should keep it in mind. So, as it is toward the direction of this observer, that is why these things here I am representing by a dot line, here you can see. So, as there are two different weld both side, that is why what happens, this two dot I have used in same angular position in both the weld. Okay. So, this is the free body diagram. So, in this free body diagram, why I am putting these things, if the applied load is P, which is away from the observer perpendicular to the plane of this paper, then the resisting force on the weld, it should be toward the observer perpendicular to the paper. This you should keep it in mind, because this structure should be in equilibrium. That means, whatever the applied force should be there. So, applied force should equal to the resisting force developed inside the weld structure. This you should keep it in mind, because what is the definition of a stress we know, because the definition of a stress in a structure generally we define like this. Once we applied a external load in a structure, then inside this structure there is developed some resisting force which is opposite to the direction of this applied force. Okay. That resisting force per unit cross sectional area of that structure is called stress. Similar things also here we are considering. Here we are considering, as the applied force is P externally towards the plane of this paper, perpendicular to the plane of this paper, which is away from the observer. That is why here the resisting force should be toward the observer direction. That is why one things I am representing by cross, another things I am representing by dot. Dot generally represent towards the direction perpendicular to the plane of paper toward the observer. This you should keep it in mind. Now, this applied force. So, here we should apply a principle of equation of equilibrium, that you can say, or we can use here equation of equilibrium. That means, summation of all forces at a particular direction should be equal to 0. That things here we can use, because these things should be in equilibrium. So, applied force here should be equal to resisting force. So, applied force should be equal to your resisting force, which is inside the welds. So, that is why here I am written as the applied load is P. So, in this two weld there will be P by 2 loads. Now, we are going to find out what is the direction of this theta where this maximum stress is acting. This we are going to find out. So, for finding out these things, here I am drawing the fillet. We know this fillet which have a equal leg length. So, this is AIS, this is also AIS. Let this fillet here I am representing as A, B, C. So, these things here only I am writing A, B, C. Now, let us consider this plane where this P by 2 is acting, which makes a angle theta with this horizontal axis. So, this is theta, which makes a angle theta with horizontal axis. Now, here you see this is leg length AIS, this is also leg length of the fillet is AIS. Now, I am considering this plane which I am representing here by E. Now, I am taking a perpendicular which is ED. This perpendicular is on the line BC, which I am showing here. Okay. Now, from the similarity of triangle, from the similarity of triangles, that is triangles A, B, C and triangle E, D, C. From this what we can say, as this AB is equal to BC. So, this angle what it is called, angle ACB should be equal to what? Angle ACB should be equal to 45 degree, correct. Now, from the similarity of two triangle, what we can say? We can say as AB is equal to BC is equal to ACE. So, here we can write DC is equal to your DE. How we can get this thing? From this similarity of two triangles, generally we are getting DC is equal to DE, because from the similarity that is very well known too. So, I am not going in details further. So, here we will find out a relationship. What we can say, that ACE we can write as, this leg length ACE we can write as what it is called, BD plus DC. Now, let us consider the plane at which this P by 2 is acting. This is the plane. This plane, let this plane have a thickness, let the plane have a thickness, that is BE. This plane thickness here I am representing by a word, that is T dot. Okay. So, this BE plane thickness of this weld section, which I am representing by T dot. Now, this ACE we can write, this ACE we are getting. So, ACE we can write in terms of T dash, like you see. So, BD we can write as T dash cos theta, correct, and DC we can write as, we know DC is equal to DE. So, DC also we can write as T dash sin theta, because we know DE we can write DE is equal to T dash sin theta, that you can easily get from this triangle itself. So, we get the relationship between ACE and T dash. This T dash is the plane of this weld which makes a angle theta with this horizontal axis, that is you can say with this horizontal leg BC. Now, we will find out, due to this force P by 2 in this one weld, because in this one weld there is acting a force P by 2, which I have already shown in figure B, you can see. So, this P by 2 will create a what it is called shear stress, because you see this P by 2 is the generally in this P by 2, this P by 2 generally acting in this plane which is parallel to this plane, you can say, that means along the parallel to this plane. That is why what happens, this P by 2 will create a shear stress along this plane of this weld. So, what should be the shear stress of this what it is called BE plane of this weld? So, the shear stress tau, which is along BE plane, which is along the BE plane of the weld. Okay. So, this tau shear stress we can write as, this is equal to your P by 2. From this free body diagram of B, we can say in this in one weld, if the external force is P, then in one weld there will be P by 2 force, because there are two weld we consider, that is why here it will be P by 2 force. So, the shear stress on this weld will be P by 2 divided by the cross sectional area of this plane, which makes a angle theta with this horizontal axis. So, what should be the cross sectional area? So, let the cross sectional area of this plane BE, which I am representing as ABE. So, the cross sectional area what we can write? So, ABE we can write as, AB is the cross sectional area, I am writing cross sectional area of this BE plane of this weld, which I am representing as ABE. So, ABE will be your how much? We can write as length of the weld into what? T dash, thickness of this BE plane. That is here you can write as L into BE. So, L into BE you can write, L into BE you can write, or you can say L into T dash. So, that things here I am writing. So, P by 2 we can write P by 2 divided by your cross sectional area equal to your A by T dash. Now, this T dash I will represent in terms of A's. So, from this equation 1, let this is the equation 1, we know from this equation 1 we can write T dash is equal to your A's divided by what? Divided by cos theta plus sin theta. Okay. So, this I am representing in equation number 2. So, here we are from equation number 2, from equation number 2 we can write, we can get what? Tau is equal to P by 2 divided by L. Instead of T dash I am finding these things in terms of A's, which is A's by cos theta plus sin theta, correct. So, these things we can get as P cos theta plus sin theta divided by 2 into A's into L. This we can get like this, 2 into A's into L. So, this is the shear stress in plane BE of this weld. Okay. This is the shear stress in plane BE of this weld, which I am representing by equation number 3. Now, to find out the angular position of this maximum shear stress, or we can say to find out the maximum shear stress, what are the things required to do? We have to derivative equation 3. So, differentiate equation 3 with respect to theta and make it equal to 0, make equal to 0. Then what we can get? So, to get maximum shear stress, generally here I am writing to get maximum shear stress and its position, we are generally differentiating equation 3 with respect to theta and make it equal to 0. What we will get? So, once we differentiate equation 3, we can get del by del theta equal to your P by 2 into H L. So, this will be your cos theta will be minus sin theta derivative and plus sin theta will be plus cos theta once we derivative sin theta with respect to theta. So, this should be equal to 0. So, once we make this equal to 0, we are getting here sin theta plus cos theta minus sin theta plus cos theta will be equal to 0, because we know this P by 2L is, this should not be equal to 0. We know if the multiplication of two component or two things is equal to 0, then either this part will be equal to 0 or this part equal to 0. As this is not equal to 0, so that is why we can write minus sin theta plus cos theta equal to 0. So, from here what we can get? Here we can get tan theta equal to your 1. So, tan theta 1 means we can write tan 45 degree. So, once theta equal to 45 degree, then generally what it is called, your tau will be maximum. So, you can say for theta equal to 45 degree, we can say tau is equal to tau max, correct. This you should keep it in mind. So, what we can prove that maximum shear stress in parallel fillet weld is acting at a angle theta with horizontal axis. How we are getting? from this derivation we can get this thing. Now, we will find out what is the maximum shear stress. So, what we got, tau is equal to, we got from the previous slide, you can say P by 2 H L sin theta plus cos theta. This we got generally from previous slide, you can say, that is from equation number 2 we get these things. So, this is equation number 2, here again I am writing. Now, we know tau is equal to tau max, where when theta equal to 45 degree, correct. Now, what is the tau max value? So, tau max will be here, we are putting this theta equal to 45 degree in equation number 2, we can get tau max is equal to P sin 45 degree plus cos 45 degree, correct, divided by 2 into H into L. Now, we know sin 45 degree equal to 1 by root 2, and we also know cos 45 degree also 1 by root 2, this is divided by 2 H L. So, we can get P 2 root 2 into 2 H L, correct. So, this 2 will be cancelled out, we are getting P by root 2 value is 1.414 H into L. So, the maximum shear stress what we are getting here for a double fillet weld, for a double fillet weld, if it is subjected to a parallel force P, then what happens, the maximum shear stress will generate in this fillet weld, which makes a angle theta with the horizontal axis, and this maximum shear stress inside this plane will be your P by 1.414 H into L. So, this is the maximum shear stress. So, tau max for parallel fillet weld will be your P by 1.414 H into L, where H is the leg length and L is the length of weld, and P is the equal to externally parallel load, you can say. That means, why I am writing parallel, because it is parallel to the line of this weld. So, what we got, what is the maximum shear stress and what is the plane for parallel fillet weld, this maximum shear stress is acting, that we can find out by using this above methodology. Okay. So, what we can prove that in case of parallel fillet weld, the maximum shear stress is acting at a angle 45 degree with horizontal axis, and its magnitude is P by 1.414 H into L. Okay. Now, we will solve some problem for parallel fillet weld. So, first of all we will solve one problem on parallel fillet weld. After that, we will go to discuss about how the stress distribution in case of transverse fillet weld. So, this problem first we will solve on parallel fillet weld. So, this is an example of this parallel fillet weld problem. What is the problem statement? The problem statement tell like a steel plate 100 millimeter width. So, here the width of this steel plate is 100 mm and 10 millimeter thick. So, this steel plate width is 100 millimeter and it has a thickness 10 millimeter. So, here you can say thickness of the plate is 10 millimeter and width I am writing W equal to your 100 mm of this plate is welded to another steel plate by means of double parallel fillet weld. Always keep this thing in mind. Double parallel fillet weld means once two welds are there, this is one weld, this is another weld. Okay. So, this double fillet weld which are parallel to each other, and why this is parallel fillet weld, because here the load which is acting here, this is parallel to the length of this weld. So, by definition we can get this thing. So, here a double fillet weld as shown in figure, here you can see. So, here width of this plate is also given. So, width of this plate is given as, here you see, here I am writing 100 mm. Okay. Now, the plates are subjected to a static tensile force 50 kilonewton. So, this is a force which is acting here 50 kilonewton. As the force is parallel to the length of this weld, that is why it is called parallel fillet weld actually. So, what are the things required to do? So, here external load P is equal to how much? 50 kilonewton. This is also given. So, determine the required length of the weld. So, we have to find out what is the length of the weld L. So, we have to find out what is the length of the weld L. If the permissible shear stress, so here permissible shear stress tau permissible, I am representing tau P. So, tau P here is 94 MPa. So, 94 MPa we can say, 94 MPa means Newton per millimeter square. This you should keep it in mind. So, here what are the things required to find out? We have to find out what is the length of this weld, so that it can sustain a load which is tensile in nature externally. Now, here as this load is parallel to the length of this weld, so it will create a shear stress, correct. Now, we know, now we will solve this problem. For solving this problem, we know this strength equation of this weld. So, strength equation of this parallel fillet weld, we know P is equal to 1.414 that is tau P into what is called H into you can say L, correct. This relationship already I have discussed in last lecture. That means strength equation in case of double parallel fillet weld, generally the strength equation is equal to your 1.414 permissible shear stress tau P into H into L. This already I have discussed. How this things is coming, that is also very well known to you. So, from this strength equation, this is called strength equation, we can say, for double parallel fillet weld, double parallel fillet weld. This I have already derived in previous lecture. So, here P is given. So, P here 50 kilonewton. So, 50 kilonewton, here I am writing 50 into 1000, that means you will be in Newton. So, here this 50 kilonewton in terms of Newton you can write as 50 into 10 to the power 3 Newton, correct. This will be equal to 1.414. Here tau P I am representing in terms of Newton per millimeter square. So, tau P means permissible shear stress. So, 94 here I am directly putting. Here H is also given. So, here generally H generally is the leg length of this weld. Generally we know leg length of the weld equal to the thickness of this plate which is going to weld in this another plate. This I have already discussed in previous lecture. So, here the thickness of the weld which we are going to connect with another plate by parallel fillet weld is given as 10 millimeter. So, this 10 millimeter here, this will be equal to your thickness of the plate should be equal to your leg length here H. So, these things also here I am putting. So, 10 is equal to your leg length of this fillet weld. This is already discussed in previous lecture. This into our L. So, from this equation we can easily find out what is the L value, length of this weld. So, here length of the weld we are getting as 37.02 millimeter, because you see these things also we put in terms of millimeter and this thing also we put in terms of millimeter. So, whatever the length here it will come, it will be also in millimeter. This you should keep it in mind. So, from here what you can get, if we make a weld whose length is 37 point this millimeter, then generally what happens, if L equal to this, then what happens, this structure can sustain a load 50 kilonewton. But here always keep it in mind, that means before going to design this final leg length, here you have to consider both starting and what it called end run weld length. What I am telling, understand? That is why here I am just writing these things. So, the final length of this weld to sustain this 50 kilonewton load should be equal to, generally by considering the starting and stopping of the weld run. So, here I am just writing. So, final length should be, so adding 15 millimeter, this I have already discussed in previous lecture itself, 15 millimeter of weld length for starting and stopping of the weld run. Weld run, the length of the weld is given by, so the final length of the weld is given by how much, 37.04. Here I am writing LF, let us final length. So, 37.02 plus 15. So, this will give us 52.02 millimeter. So, this you should keep it in mind. So, once your final length of this weld will be your 52.02 millimeter, then what happens, your weld will be in safe side due to the externally applied load 50 kilonewton. So, let us you are in industry. So, there you have asked to find out these types of problem. So, what should be your final length? So, you should always keep this thing in mind. You should add this 15 millimeter based on the calculation which you are getting by using strength equation, whatever the length you will get. With that, you have to add another 50 millimeter for each weld. So, with 2 weld are there. So, 2 weld for each weld there will be 15 millimeter extra weld length you should consider in your final design. Then your structure will be fully safe. This you should keep it in mind. Okay. Now, we will discuss about strength of transverse fillet weld. So, strength of transverse fillet weld, what is the definition of transverse fillet weld? That already I have discussed. So, the transverse fillet weld means if the load is acting in case of weld, if the load is acting perpendicular to the length of this weld, then that types of that is transverse direction, that is that types of fillet weld generally called transverse fillet weld. Here you can see in this figure A, here I am showing, here this is a fillet weld length. Okay, let the length of this fillet weld is L. It is subjected to a load which is perpendicular to this length direction, you can say, which is P. Now, here we are interested to find out what is the strength calculation, or what is the strength equation of this transverse fillet weld. Now, let us consider for single weld here. So, always we know, here I have written where a transverse fillet weld subjected to tensile force, here I am showing P, which is shown in figure here. So, this is a tensile force. So, as it is a tensile force, so inside the weld there will be a resisting force which also should be in tensile in nature, correct. So, the transverse fillet weld are subjected to tensile stress. So, this tensile stress generally will be acting, generally this tensile stress magnitude will be maximum where the minimum cross section of this weld are there. So, we know in case of fillet weld, the minimum cross section area is its throat section. cross sectional area you can say. So, minimum cross section of the weld is at the throat you can say. Therefore, the failure of the due to this tensile stress of this plate should occur at the throat section, because here at the cross sectional area in this throat is minimum. So, here the maximum tensile stress will develop. So, where will be the maximum tensile stress? There will be generally chances of failure more, correct. There also there generally chances of failure will be occur. That things here only I have written. The minimum cross section of the weld is at the throat. Therefore, the failure due to tensile stress will occur at the throat section. So, the tensile stress here I am representing in terms of sigma t. So, here I am writing tensile stress at throat, which I am representing sigma t. This will be your how much? This will be for a single fillet weld. For single fillet weld we can write P by your let throat thickness is here I am representing as T. So, here this is T, I am representing throat thickness, okay. And leg length is H, leg length here I am representing as H. So, here you see, so we can write this throat thickness into length of weld. Here one thing you should keep it in mind, here we are just finding for single fillet weld first, after that we will convert this thing into double fillet weld. Okay. So, here for single fillet weld the tensile stress will be P by T into L. So, here we know this throat thickness we are representing in terms of leg length. So, P by we know this in terms of leg length T will be written as 0.707 H. This calculation already I have shown. So, this we can write as in case of in terms of leg length 0.707 H into L, correct. So, for single, so tensile stress for single transverse weld, okay, singles transverse weld here I am writing. After that I will just convert this thing into double fillet weld. So, here what we can write? Here we can get P equal to your 0.707 sigma T into H into L. This is called a strength equation for single transverse weld. Now, we know in case of transverse weld there should be two weld, then only your structure will be in proper design, or it will not fail, or you can say generally in case of transverse weld there should be two transverse weld. So, for double transverse weld this strength equation, so for double transverse fillet weld, the strength equation will be just let us P, here I am representing P d. So, P d for double fillet weld, so P d will be your 2 into, because 2 equal length, let us 2 equal length welds both side of this 2 plate are there. So, this is one fillet weld, this is another fillet weld. So, this is one, this is another. So, the strength equation for double fillet weld will be your 2 into 0.707 sigma T into H into L. So, this is generally tensile stress, it is generally normal stress, it is not what it is called shear stress. So, this is a normal stress. Why? Because it is generally normal to the section that we can consider. We are assuming this force is acting normal to the section of this throat. So, this is a tensile normal stress, that is why we are representing in terms of sigma T. Okay. Here we are not considering the shear stress, because shear stress is acting on the force is along the plane, but here it is generally we are assuming this force is acting perpendicular to the plane. Here it is like this. So, here how much we are getting? So, the strength equation for double transverse fillet weld will be your 1.414 sigma T H into L. This you should keep it in mind. Okay. So, usually we know there are two welds of equal length on two sides of the plate, as shown here already I have shown. That is why in case of double transverse fillet weld, the strength equation is coming 1.414 sigma T into H into L. So, this I am representing by equation number 2. Now, we will solve some problem on this transverse fillet weld, then it will be more clear to you. Now, let us consider two steel plate. This is one steel plate, this is another steel plate. It has a width of 120 millimeter and it has a thickness of 12.5 millimeter. So, always you should keep it in mind, here thickness is equal to H, that means equal to your leg length, which is equal to your 12.5 millimeter, it is given, and also given your width of the plate. Width of the plate I am representing W as 120 millimeter. This is generally these are joined together by means of double transverse fillet weld. The maximum tensile stress for the plate and the welded material should not exceed 110 MPa. So, here sigma T, you can say sigma T which is permissible, that means it should not exceed this sigma T value in this weld as well as plate material. So, this is the permissible tensile stress, that means this mass stress it can permit. Beyond this, once it goes, if the stress level is beyond this value, then your structure will consider as failed. What I am telling, understand? So, here this is sigma T is given as 110 MPa. So, 110 MPa means what? 110 Newton per mm square you can write. Okay. So, find the required length of the weld if the strength of the weld is equal to strength of the plate. So, here we are considering strength of this weld equal to the strength of the plate. So, here these things we should note actually. So, here what are the things given? Strength of weld equal to your strength of plates. So, what is the strength of plate? So, strength of plate means if this this plate, this is a plate, you see, this is a plate. So, how to find out the strength of plate? If it is subjected to a load P, if it is subjected to a load P, and if this plate here it is given as this plate, this things is given as 120 millimeter. Okay, and it has a thickness also given, it has a thickness of this plate is also given. The thickness of the plate is given as how much? The thickness of the plate is 12.5 millimeter. Now, if this plate subjected to load P, which is how much? If it is subjected to load P, then what should be the stress inside this plate? That we can easily find out, because we have to find out what here the maximum tensile for the plate. Here we have to find out the required length of the weld. Okay. Here we have to find out the required length of the weld. So, here one thing you should keep it in mind, whatever the stress due to this external load P inside this plate, this mass stress should be equal to the weld stress, or we can say weld strength due to this two different or two equal length transverse plate weld. So, first of this, so this concept generally we will use here. So, here for this plate we know this strength will be how much? So, strength will be generally P equal to will be your sigma T into width of the plate into thickness of the plate, thickness of the plate. So, this thing should be equal to what? This thing, so here I am, so strength of the first strength of the plate is this mass. So, strength of the plate here I am representing as strength of plate, okay. Here PP I am representing. So, strength of weld will be how much? So, strength of double transverse weld will be your PW is equal to your how much? PW also we know as 1.414 sigma T into H into L. So, this is generally for plate strength, this is generally for weld strength, this is weld strength, okay. And we have to find out what should be the length of this weld, this L. So, we know from this weld strength equation, we know just before this slide I have already shown PW is equal to 1.414 sigma T into H into L. So, for plate it has also a strength which have a width is also given, which I am finding as PP, which is sigma T into W into H, correct. So, these two strength once we equate, we can get a relationship which I am showing here. So, here what we can write here, generally by problem definition itself we are getting PW is equal to P into that means strength of weld should be equal to strength of plate. So, here strength of weld is how much? 1.414 sigma T H into L. This should be equal to your sigma T into W into H. So, here everything is given, you can see. So, from here we can easily find out what is the L, because this sigma T will cancel out, H will be cancel out. So, here generally 1.414 L, this should be equal to your W. So, here L we can write as W is given, width of the plate is given as 120. So, this divided by 1.414. So, this will be your 84.87. So, once we apply the length of the transverse plate is equal to 84.87 millimeter, then we can get the strength of weld equal to your strength of the plate. That means, here if the weld length L equal to 84.87 millimeter, then whatever the strength will be in your weld, that strength should be equal to your strength of the plate. But here for generally considering the starting and stopping weld run, here we have to add here 15 millimeter for each length of the weld. So, here generally final length, or what we can say, so the final length of your design weld, you can say final length of your design length of weld will be your L plus 15. So, it will be generally 84.87 plus 15, this will give us 99.87, or you can consider as equal to your 100 mm. Here I am writing this thing, adding 15 millimeter for starting and stopping of the weld run. The weld run. So, this way generally we can easily find out what is the required property for a transverse fillet weld. Now, if it is if the length is given, then what should be the maximum load it can sustain, that is P, that also we can easily find out. So, by this method generally we can design a transverse fillet joint, okay, the transverse fillet weld you can say. Now, we will solve another problem. This problem is the combination of this transverse fillet weld as well as what it is called parallel fillet weld. So, what is the problem statement? A steel plate 100 millimeter width, here it is given 10 millimeter thickness. So, here W is given as 100 mm So, this is a plate, here this width 100 mm, here you can see. Okay. This has a thickness, I am representing in terms of H, because generally leg length and thickness should be equal, that is why I am writing this thing 10 mm, is joined with another steel plate by means of single transverse. You see, this is one single transverse and double parallel. See, this is one, this is another one, these are all parallel to this load P. So, double parallel fillet weld. So, one is single, another double parallel fillet weld. The strength of the welded joint should be equal to strength of the plate. So, here also it is given strength, these things you should just note it down. So, here it is given the strength of welded joint should be equal to strength of the plate. So, strength of welded joint equal to strength of plate. Whatever the problem I have solved in previously, similar condition here also it is given, strength of plates. Okay. The permissible tensile and shear stress. So, here tensile stress, permissible tensile stress is 70 MPa and shear stress permissible tau p, here I am writing as 50 MPa. Why these two stress are given? Because here one is transverse and 2 is parallel. For parallel this tau p will be required, for transverse generally sigma t will be required, that is why. So, find the length of each parallel fillet weld. So, we have to find out what should be the length of this parallel fillet weld, that means each parallel fillet weld what should be the length. Assume the tensile force acting on the plate as static. So, here the load whatever P here is showing, this P is considering as static load. So, what are the things required to do? You have to find out what should be the length of parallel fillet weld. So, first of all we will find out the tensile strength of the plate. So, here I am writing strength of weld joint lead Pw should be equal to strength of plate Pp. So, here first of all we will find out what is the strength of plate. So, strength of plate Pp. So, here I am writing strength of plate. So, the strength of plate will be how much? Everything is given. So, here generally strength of plate is generally, as this plate is subjected to a tensile force, here you can see, here I am just drawing. So, this is a plate. So, it is, if it is subjected to a tensile force P and if it is a thickness T and width W, then due to this tensile force P, inside this plate there will be developed some resisting force. So, that resisting force generally you can write as which will be equal to this externally applied load P. So, due to this resisting force whatever the stress will be developed, that stress will be your P divided by what? P divided by cross sectional area of this plate. So, cross sectional area will be your W into here plate thickness is considered T equal to your H. So, you can write P by W into H. So, here then the strength of the plate will be your, you can write, so P will be, this will be your sigma T. So, what we can write? So, here P we can write as Pp will be, we can write as sigma T into W into H, because here it is already given the strength of what is called plate as well as strength of weld are same, that is why this thing. So, Pp we can write as sigma T into W into H. Okay. So, this once we put the value what we can get. So, sigma T is given as 70 MPa and width is given of this plate is 100 and leg length or you can say thickness of the plate is given as 10. So, this will give us a value which is equal to your 70,000 Newton, correct. Now, we will find out, so this is 1. Now, we will find out second step. So, this is a step 1, let us. Okay. Now, second step we have to find out the strength of transverse fillet weld, and after that we will find strength of parallel fillet weld. So, first of all we will find out strength of what is called, first of all we will find out strength of transverse fillet weld. So, first of all strength of transverse fillet weld. So, strength of transverse fillet weld, let us, here I am representing PT, as there is only single transverse fillet weld. So, for single transverse fillet weld we know the equation is 0.707, and this transverse fillet weld subjected to tensile stress. So, sigma T into H into length of this transverse fillet weld. So, length of this transverse fillet weld I am representing LT. Okay. So, this will give us PT equal to your 0.707, sigma T is 70, H is given as 10 already given, and L of this transverse fillet weld already given as 100 mm. Okay. Now, if we just put these things, we are getting this transverse fillet weld strength as 490 Newton. Now, we will find out what is the strength of parallel fillet weld. So, third step, strength of double parallel fillet weld. Here I am writing double parallel fillet weld. So, strength of double parallel fillet weld, here I am writing P parallel fillet weld, just here I am writing PD, okay, double parallel fillet weld PD I am writing. So, PD equal to, you can say, we know already the relationship 1.414, and parallel fillet weld generally subjected to shear stress. So, permissible shear stress, here I am writing tau P into your H into length of parallel fillet weld. This I am representing as, let us, here I am representing this length of parallel fillet weld as LP. So, here this LP, this we are here we have to find out this LP value. What is this LP value? Now, from this relationship what we are getting, 1.414, tau P is given as 50, and your leg length of this fillet weld is generally thickness of the fillet, which is 10. Now, here in first step I have shown that, okay, strength of weld should be equal to strength of plate, correct. So, here strength of weld is how much? Strength of weld should be equal to your strength of transverse plate plus strength of double parallel fillet weld, correct. So, strength of transverse plate already I have discussed PT, and strength of double parallel fillet weld is PD. In third step I have already shown. So, PT plus PD will be equal to your strength of PP. So, what is PT? We know for PT we are we have already calculated as 49490, and PD is 1.414 into 50, 500 into LP, you can say. Okay. This will be equal to your just strength of the plate, which is actually 70,000. So, from here we can get length of the parallel fillet weld as generally equal to your 29.01 mm. So, here also one thing you should keep it in mind, that means here also you should add 15 millimeter for starting and stopping of the weld run. So, here after adding 15 millimeter for starting and stopping of the weld run, the final length of the fillet weld, here I am just writing LF. So, final length of the fillet weld will be 29.01 plus 15 millimeter. So, this will be equal to your 44.01 mm. So, if your length of the weld by considering a starting and a stopping effect, then generally your final length of the weld should be 44.01 mm. This you can consider as 45 mm also, no problem. If it is little bit higher side, does not matter. Okay. So, this way generally you can easily find out what should be the design length of fillet weld if it is subjected to some load. So, if you are in a industry, if they ask you to design a transverse fillet weld length or transverse fillet weld dimension by considering some specific application of loading, then by considering this concept you can easily find out what should be the length of that weld, what should be the dimension of this weld, and if you are provided all the required data means what is the permissible strength of weld, what is the permissible strength of plate. So, by considering this methodology, you can easily design a structure, or you can say you can easily be able to design a welded joint. This you can say. Okay, next lecture I will start once a welded structure subjected to eccentric types of loading, then how to find out the required length or required dimension. So, next class I will discuss about how to design a welded structure which is subjected to eccentrically loading. Okay. Thank you.